And we're back. Welcome back to Swarm's AI Career Triathlon. This is the second presentation for today. And in the first presentation, we had a presentation prepared by and delivered by Sivaram Anadurai, and he told us a little bit about the emerging trends with AI native startups and how can you keep yourself sharp and enable an easy transition into those kinds of environments. Now we're going to be moving into a little bit more of a technical presentation on the power of knowledge sharing. Inevitably, we're going to see some elements of social and technical because knowledge is something that is born and lives in our minds. And we have the lovely Bilal to give this presentation. So without further ado, Bilal, I'm going to share your screen and you should be able to. Your screen is visible if you want
Okay.
to. Perfect.
Can you see my script?
Visible. Yep.
Okay. Okay. Good.
So
Good.
excuse myself, and the floor is yours.
Okay. Thank you, Joaquin, for having me here today. So my name is Bilal, and I work as a senior knowledge graph architect, focusing on designing semantic models, ontologies, and knowledge-driven architectures that help organizations structure and operationalize their data for AI systems. Today, I will walk you guys through short but important set of things around how we build intelligent systems, and in fact, not about how we build, but in fact, how we need to think, okay, about AI project and AI systems. So today's session is organized in six parts. Okay, first we'll examine the current state of AI projects. Okay, and discuss why many initiatives struggle to deliver sustainable business value. Next, we'll explore why projects without semantic layer often fail despite having access to large amount of data and advanced AI technologies. Then we look at the relationship between fragmented knowledge and fragmented AI and how disconnected information limits intelligent decision making. After that, we'll introduce a knowledge architecture as the missing foundation for building scalable, trustworthy, and explainable AI systems. So the advantages of starting with business knowledge before selecting technologies. And finally, we'll discuss the future of enterprise intelligence and how organizations can prepare for the next generation of AI-driven systems. So let's get started. In fact, I like to, before starting, I like to share some numbers and statistics about the state of AI project in our currently. There are a lot of statistics, and in fact, I selected three of them, okay, with clickable links here. After this present, I will share this presentation, and then people can access to these statistics. But in fact, I selected three important challenges in AI adoption. So for example, the last year, 42% of companies abandoned the majority of their AI initiatives, and the average organization scrapped 46% of its AI proof of concept before they ever reached production. And based on Gartner studies, Gartner predict that 60% of AI projects will be abandoned by 2026, specifically due to the bad data. And what is the bad data here? It's defined as the data that is fragmented, the data without context, and the data that has poor governance. And the third one is about the pilot failure. Okay, so according to MIT's NANDA study, 95% of generative AI pilots fail to reach production or deliver measurable return of investment. And here, the question that we need to ask ourselves is, what is the cause problem? What is the root cause of these problems? So the primary obstacle cited for these failures are fragmented data, inconsistent metric definitions, and poor data quality. And this exact three problems semantic layer is architected to resolve. So here, if we can, to sum up, all these statistics are agreed on something very important about the problem it's not in the tools, the problem it's not in the technologies, but the problem it is embedded in the data quality. And in order to solve the data quality problem, currently we are hearing a very important concept that is semantic layer. So what is a semantic layer? What does that mean, semantic layer? Does the ontology mean semantic layer? Does knowledge graph mean semantic layer? So here I just collected this in fact definition using AI ChatGPT, and I asked ChatGPT, in fact, what is a semantic layer, and he gave me something. It gave me something very important. Semantic layer. Is something that can help you in order to bring meaning to your data. So from data to understanding. So it's like a semantic layer. It's like space, okay, and the system with descriptive information, classification, and relationship roles. And I will talk about these things in details in the next slides. But just in order to keep things simple, the semantic layer is the system, okay, that can help us to bring data or to bring the meaning to the data that we have. So now, after knowing what is the semantic layer, why, in fact, in the before mentioned statistics, why the cause problem it was about semantic layer, why the problem is the data and not another thing, okay? So here I will tackle three important points, okay? The risk number one is the logic hallucination. So without semantic layer to define without semantic layer to define a load interpretation, AI agents, for example, or AI systems often act on, on statistically probable but factually incorrect interpretation of business data. So as we know, the LLM models are something that is relied on probabilistic, okay? So the results are just based on probabilities, which means that the probabilities, it's not something that we can trust, something that can be helpful, but we can't trust. And in order to trust these probabilities, we need to add an extra layer, we need to add something else to make our AI systems relevant in their answers. So the first problem is the hallucinations, and the second problem is about business reality. As we mentioned before, 95% of pilots fail often because they cannot translate business problems into technical execution. So semantic layer bridges this by mapping technical data schema to business concept that we can call ontologies, preventing the prototype graveyard where models work in isolation but fail in a real world workflows. Here, this is something very, very important because without schema, without a business, with definitions, without glossaries, without a shared vocabularies, the LLMs will invent, okay, the definitions that are away, in fact, sorry, away from the vocabulary and away from the context that we are targeting. So for example, the customer in company X, it's not similar to the customer in company Y, it's not similar to the customer in company Z. And in order to make our system understand these things, we need shared vocabulary. We need to connect, okay, our data in order to shape a real business. And the third one, it's about unscalable glue code, which means that the projects without centralized semantic definition rely on hard-coded rules and manual data cleaning, and this approach becomes unmaintainable at scale, contributing to the 80% failure rate as projects move from pilot to production. And this is also one of the risks that people are facing. I added, guys, some references here in order to understand very, very well what is a semantic layer, and also in order to understand and read more about these risks. And you will find more risks about why AI projects in fact fail. Then here, the question that we need to ask ourselves here, if the AI projects are failed because of the lack of the semantic layer, what is the role of the semantic layer? Why we need semantic layer? Here, I selected to touch two important points. The first point is the context versus access. And this is something very important because just this year, Gartner claimed something very important. They see that 2026 is the context, is the year of the context. Okay, so the context, it's very, very important. And the question that we need to ask is how we can achieve context and how we can contextualize our data. And here, without semantic layer, AI models have access to data but lack the meaning to interpret it. And this forces the AI to guess a definition, guessing what revenue, given what is churn means in specific context. And guessing leads to hallucination and conflicting logic. And the second point is the inconsistent logic. AI initiatives, in fact, often fail because the systems feeding them don't agree on what the data means. We don't have, in fact, shared vocabulary. We don't have a formalized definitions for all the entities and the concepts that we are adopting inside our companies and our organizations. So one source notes that this semantic data modeling issue is rarely treated as a foundational problem until it breaks business logic, causing AI models to amplify conflicting data fragments. And this is in fact true, and we can see why this can break the AI systems. And in order to sum up and summarize, we can say that the semantic layer can help us to build the context in order to improve the accessibility, the findability, and interpretability of the data. And also, it could be helpful in order to build a consistent logic, okay, based on shared vocabularies and entities. So this is what is semantic layer. This is the role of the semantic layer. But why we don't achieve, and a lot of startups or organizations find difficulties in order to build semantic layer. So if this is the semantic layer, so why? Here I will talk about the paradox of the information age. And here I want to mention something very, very important. We agree on something. All organizations generate more data than before. Okay, and but even though they generate data, they can't understand this data. Their system can't interpret this data. So here, we don't have an AI problem, but we have a fundamental knowledge problem. So the problem is rarely a lack of information. The problem is scattered knowledge. And here I will tell you a story. Okay, in one of my experiences, okay, with one of the startups, the CEO told me that I have a knowledge graph, I have everything good, so we need just to build our AI system in order to get relevant result and the relevant interpretabilities. And then I found something very uh, I found something dangerous, to be honest. They only store document into a database and enrich this document with metadata, but they don't have any knowledge about the content of this document and how they can model the content of the document itself. The only thing that they did, they stored the document and they enrich the document with the metadata, like for example, the name of the document, the topic of the document, the year, publication year of the document, and so on. This metadata can only be helpful if you want to improve the accessibility to the most appropriate document, but it will not help you in order to understand the content of this document, and also your AI systems will not understand the content of this document. And here, the problem that we need to solve, it's the problem about the knowledge sharing. So what is the knowledge sharing? So the knowledge sharing is the process through which systems and teams exchange insight, experience, and contextual understanding. And this is the most important thing, the contextual understanding. You have the document stored with enriched metadata. It doesn't mean that you have a context. Okay, you have just metadata enrichment that can help the system or the AI system to access rapidly to the document. And you can, for example, with this representation, you can solve topic modeling problems or something like that. So the main problem here is how we can make our document readable, understandable by the machines, our machines, in fact. And in this context, we need to apply what we can call the FAIR principles: findability, accessibility, interoperability, and reusability. So the knowledge is should be accessible, understandable, reusable, and actionable. Okay, and in order to achieve that, in fact, you need to go inside this document and understand them. So here we are suffering from the problem of the data fragmentation. We have different sources of information, document, emails, but you only store these sources with the metadata, which cause the problem of the data fragmentation. So what is the anatomy of the fragmentation here? The first point is that in this experience, in fact, we have we had in fact a knowledge silos. So departments often develop their own processes, terminologies, tools, and repositories in silos as island. Valuable knowledge becomes trapped with teams, creating isolated knowledge islands that are difficult for others to access, which means we have a fragmented systems. Critical information may be distributed across emails, shared drives, wikis. So employees spend considerable time searching for information. We have significant portion of organizational knowledge exists only in people's mind. Employees develop expertise through years of experience, but this knowledge is rarely documented. So when experts leave the organization, valuable institutional memory often disappears with them. We have the lack of the common vocabulary. So different teams frequently use different terms to describe the same concept without shared taxonomies, ontologies, or semantic models. Communication becomes inefficient and misunderstanding increases. And we have the other sources like the cultural barriers, the technology first bias, and I will touch this point also. So what is the risk and what is the danger of fragmented the enterprise context? The context, as we know, the risk is the following. If we consider these systems as these traditional systems are built on isolated tables, APIs, documents. They excel at storage, but lack cross-domain relationships and global reasoning capabilities. So when fragmented, partial context fits an opaque model, outputs appear arbitrary, decisions cannot be explained, and users lose confidence. And here, all these problems, if we are not aware of these problems, we will build something that is called the generative AI illusion. Okay, so in fact, we need to keep in our mind, we need to believe in that. The current wave of generative AI has created tremendous excitement across industry. Organizations are investing billions of dollars in AI technologies with the expectation of transforming productivity, automation, and decision making. But many AI initiatives fail to deliver expected business value. And the reason is, if we need to put the reason simply, because AI systems are only as effective as the knowledge ecosystem that support them. So if you don't have a good knowledge and strong knowledge ecosystem that is represented by strong semantic layer, so your system will not behave good. So AI needs context, reliable sources, and consistent terminology, and not just raw data. And here I came with something. If you have a fragmented knowledge, you have a fragmented intelligence. And this is that we need. So if information is scattered across disconnected systems, AI cannot access the complete organizational context. Different teams obtain different answers. Trust in AI outputs declines. Explainability becomes difficult. Business users reject recommendations. So which means you have fragmented intelligence, and you build AI system, but you build a fragmented AI system. So why we build fragmented AI system? Because we need to understand the role of AI. AI, it's not fixer. Okay, AI does not automatically fix poor knowledge management. Instead, AI often magnifies existing weaknesses. So poor data quality becomes poor AI output. Period. Inconsistent definitions become inconsistent recommendations. Period. Missing context becomes hallucinations. Period. And knowledge silos becomes AI silos. As one emergent perspective suggests, many organizations don't have an AI problem, to be honest. They have an organizational learning and knowledge integration a problem. So this is in fact the AI dilemma. Okay, and these problems, in fact, that I have mentioned, uh, uh, put our project, okay, in a situation where the project start to resist in order to continue working. And if your project start resisting, that it means you have something wrong, that you need to double check, and that you need to tackle or others. And in order to tackle this or others the problem, you need to understand the taxes friction. Okay, so the hidden taxes of friction behind these problems. And here also to be based on my text, just guys, I generated this picture using uh, Gemini. Okay, Gemini. Yeah, I gave my text and then I generated this picture. So but what I want to explain in this picture is the following question: what are the business consequences of poor knowledge sharing? So if you have poor knowledge, what are the consequences? The first consequence, guys, is the reduced productivity. So employees spend significant amounts of time searching for information, validating answers, and recreating existing work rather than delivering value. So slower decision making, repeated mistakes. So when lessons learned are not shared, okay, and this is something very important, guys. When lessons learned are not shared, organizations repeat the same errors across teams and projects. Okay, so these are the the main taxes, okay, that if we don't be aware of what the AI systems can do, and what's the limitations of the AI system, if we don't have a good and strong semantic layer, in fact, we will face these problems. So what is the missing foundation? The missing foundation is the knowledge architecture. So successful AI initiatives are increasingly built on strong knowledge foundations such as taxonomies, ontologies, knowledge graphs, mastering data management, knowledge governance framework. So these structures transform disconnected information into connected knowledge, enabling AI system to reason, retrieve, explain, and recommend. And in order to achieve that, we need to build mountain that we need to climb in order to build collective intelligence. And in order to in order to build this collective intelligence, we need to convert the data into information, the information into knowledge, and then the knowledge into shared understanding. And the shared understanding exists when multiple individuals or teams interpret knowledge consistently and align around common concepts, goals, and meaning. So shared understanding enabled coordinated decision making at scale. And then the progression can be visualized as data, information, knowledge, shared understanding, and collective intelligence. So organizations that successfully move through this progression becomes more adaptive, innovative, and resilient. So and this is the transformation pipeline, in fact. And the paradigm we need to, in fact, and in order to build this system, it's like we are shifting from the black box paradigm to glass box. In fact, I came across this title from Explainable AI from Black Box to Glass Box paper. I like this title. And this table can show the comparison between traditional architecture and the knowledge-centric architecture. So, for example, I will go to the context. If in the traditional systems context fragmented across different effects, different across different systems, but we need something that we can use in order to unify cross-domain semantic relationship. The business logic, for example, in traditional system, all the business logic, it's embedded in the application and the logic layer of the application, and this is something, in fact, very dangerous. And the knowledge-centric architecture ensures that we have explicit, visible things through formalized ontologies. And this is, in fact, the layered knowledge architecture. We need to start with taxonomies, ontologies, knowledge graphs, and AI systems. And here, and then we can build AI systems. And from this point, the question that we need to ask is changed. Okay, the, the traditional question is, do we have enough data? But this is the wrong question for now. The question now, can our organization transform fragmented information into shared understanding? Okay, and this is the main important question that we need to ask ourselves as leaders in companies or founders of startup, and why we are not asking like this question, because we have a false start point, because organizations frequently start with technology because it's tangible. Okay, it's tangible. They ask which database, which AI model, which graph technology, which cloud, but the foundational start is how do we represent our business knowledge, so that both humans and machines can understand it. And just we need to keep in our mind, technology just accelerate execution. It cannot compensate for conceptual ambiguity. So we need to forget about the technology, but we need to focus more on the conceptualization and how we build a good semantic layer. So, and here a comparison about the tech first versus the knowledge first. So in fact, to sum up, technology is easier to purchase than business consensus is to build, but skipping consensus guarantees failures, and we need to build consensus through semantic layer. And this is the knowledge first. We need the business language, good business language. We need conceptual model, and we need the technical design at stage number 3. But currently we can see people that start with the stage number 3 by asking about technology, but asking about technologies, but they skip the intermediate layer, that dramatically reduces misunderstanding, ensuring technical teams build what the business actually needs. So technology does not create understanding, it creates the understanding that already exists. So, and here the knowledge architecture stack that we need to rely on in order to build our semantic layer. So organization, in fact, frequently ask, should we build a taxonomy, ontology, or property graph? Do we need a knowledge graph? Which approach is best for AI? For me, this is false dilemma, and we need all of them. We need a hybrid system that contain taxonomies, ontologies, property graphs that we can then combine in a good knowledge graph. So taxonomies, ontologies, property graphs, knowledge graphs are not competitors. They solve different problems, operate at different levels. And this is, we need to start with classification. The taxonomy can help us to start with classification, to solve classification problem. Then the ontology, in order to define the meaning between these entities or concept. And then we have the knowledge graph in order to make the instances interact globally with each other based on the shared understanding, ensured by an ontology. So just quickly, guys, taxonomies hit a wall when answering how or why concepts are connected, because the taxonomies clarify what category an item belongs to, but lack the rules to govern semantic relationships. So and then, for example, taxonomies can help us in order to standardize the enterprise vocabulary. We have the ontologies, and then the ontologies is a formal representation of concepts, relationships, properties, and rules within a domain. They answer the question, what do this concept mean, and what constraints govern them? And but also ontologies hit wall when mapped to operational data. They define the roles but are not optimized for storing millions of dynamic real-world entities or executing a real-time graph traversal. Why I'm mentioning this point, guys, here? Because just currently I encountered some people, they consider ontology is something that we need in order to store the data. Ontologies are not for conceptualizations, are not for storing millions or real world entities. Just they help us to shape and give a good definition and formalized definition to this concept. And then we have a knowledge graphs, and in fact the core definition of knowledge graph. There are a lot of definitions. People are boring with the definitions of knowledge graphs. What is the difference between knowledge graph properties, graph ontologies, taxonomies? I think we need to bypass this problem, and we need to think more deeply now, and consider just the knowledge graph is something that can help us to answer question what specific entities are connected in the real world. But we know, but we need to understand something very important. Without shared ontology, graphs devolve into disconnected, ambiguous entities with inconsistent modeling and reduced explainability. So behind scene, in order to make your knowledge graph works good and powerful and in a powerful way, it's very important, in fact, to power this knowledge graph with an ontology. Imagine the ontology, it's like contract. Okay, imagine ontology, it's like schema, a contract that the data represented in the knowledge graph must respect the contract provided by the ontology. So the ontology is the contract that the knowledge graph must respect in order to define the real world entities. So to conclude, guys, the question that here, and to sum up, in fact, we talked about the AI project's limitations. Why do we have these limitations? How we can solve these limitations by by building a good semantic layer, and why these AI initiatives are failed. And now, in order to conclude, I want to add something, and this is the final point that I want to add. Okay, it's about the future of enterprise intelligence. So AI may be the engine of transformation, but knowledge is the foundation that makes that transformation possible. So the organizations that learn to organize, share, and connect their knowledge effectively will be the ones that unlock the full potential of artificial intelligence. So the future belongs not to the organization with the most data. I know that the data, it's very important. If you have the data, more data, it means you have an arm, okay, in your hand. But if you don't know how you can use this arms, okay, you will lose your place in the marketplace. So this is why I say the future belongs not to the organization with the most data, but to those that can most effectively connect, structure, share, and apply knowledge. And thank you.
Bilal, thank you very much for that presentation. Let's let me see if I understood this correctly, because I want to simplify things, and then I want to have a discussion with you for the remainder of the time. So, a lot of AI projects fail because there's bad data and bad data quality, bad data infrastructure, and sometimes that's the responsibility and the accountability of the organization that creates their internal applications. Other times, it's a consequence of inheriting or buying a software solution that already has a predetermined representation of the world. They have their schemas. The schemas have a different, or they have their own internal language to represent meaning of the entities that they are providing you with through the solution that you buy. Um, and
Yeah.
Very few organizations invest in a
Yeah.
means for tying all that together. You called it semantic layer. Some people call it metadata management. Other people call it the ontology. Other
yeah,
people call it many different things. But
yeah.
the idea is the same, right?
Uh,
Like,
uh, yeah, sorry for interrupting you, Joaquin. And this is one important point. Why? Because I have a reason why I'm calling it semantic layer. Uh, it's because it's not only an ontology. It's property graph. It's an ontology. It's taxonomy. It's ecosystem that contains different semantic models. Okay, and why it is a semantic layer? Because in the most cases we need hybrid system that can combine all these three organizing principles to achieve good interpretability of the data.
that's a beautiful explanation, and yeah, I'm in agreement with having a unified way of calling this thing because it's not one component. You can't just pick one and you're done. All of these different parts of the stack have a purpose, right?
Yeah,
Categories through a
exactly.
taxonomy, a controlled vocabulary to make sure you have shared vocabulary with all the different functions. And if you happen to use the same word in different functions, different silos of knowledge and data, you can at
Mhm.
least have a shared representation of what that means for each other. So you gain empathy and understanding for each other's
Exactly.
worldviews. Um, so very few organizations invest in this semantic layer. Also, very few organizations invest in the knowledge
Yeah,
management.
yeah,
Nobody documents what they do. Nobody documents their SOPs, their standard operating
yeah,
procedures, or their systems. Whenever you go into a new organization, what do they tell you? Oh, go talk to that person. Oh, go talk to that person because nobody really
yeah,
knows
yeah,
what the whole thing is.
yeah.
Um,
Uh,
you-
uh, yeah. And also there is a reason behind that, in fact. And this is one of the drawbacks of how we are using AI, because now and specifically in fact for startups, they want to go quickly to the marketplace, to the market, to release, okay, their product. But in effect, the problem, it's not in releasing the product itself, but what are the next steps, and what is the evaluation pipeline that you have in mind in order to improve this product. And when you start talking with them about like these things, okay, in most cases they can't answer. Yeah,
you know, I don't even I don't like blaming. I don't but I want to empathize and I want to understand what is the source of this systemic issue that we can't find an agreement, social contracts, knowledge management. There's no prioritization around that. I mean, is it a consequence that we don't have any anthropology classes or there's not enough I don't know.
in
We don't formally teach knowledge management.
uh,
People just go to school and they get administered a curriculum or information, and
yeah,
then
yeah,
you go like this and hope that they get a job and contribute
yeah.
to
This is
society.
yeah. This is a good point, in fact, Joaquin, and thank you for mentioning this point. Okay, uh, in order to face the AI wave, okay, we need to prepare our resources, our students, to be integrated in the marketplace in an accurate way with a solid knowledge, with the solid skills. Okay. The problem now is that the problem is coming from the student themselves, from people themselves, and from the system also. Okay. Why? Because now one of the popular things that I'm seeing these days is the following. I can see the code that excel the person that writes this code, because this code is written by the AI. Okay. So here the AI start to excel our student in performing tasks. Okay, good. We need to use AI, of course. We need to use it. Okay, but I personally see that we need to give and we need to give to our student a solid knowledge about how they can use the AI and how the AI can help them, and not only go to, for example, cursor IDE or something and start typing in order to build application. And this is something that we can find a lot on LinkedIn. People mentioned, I built this week 10 AI agents, and the other said I built this week something similar to the GitHub. Okay, but if we will start talking with them, they can find the gap. Okay, so the AI start to excel, start to underestimate our resources that are student. Okay, and in this case, if you go to, and a lot of companies, in order to be hired, you need to go over an interview process, and they will quickly cancel you from the first stage. Okay, and this is something that we need to be aware of. The problem, it's not uh, in AI. The problem is how we can ensure a good protocols, knowledge management systems that can help us in order to prepare our student to be integrated in the marketplace.
I think this is a much broader conversation, and I think we're going to get into that in the panel discussion a little later.
Yeah,
But thank you, Bilal, for preparing this presentation on knowledge management as a technical, you know, infrastructure, the semantic layer, and all these things. There's a lot to unpack there. So yeah, we'll get into that with Honey, and we'll see
yeah.
you all very soon. We're just gonna
Thank
take a
you.
little break.
Thank you. Thank you. Bye.
Cheers.